this? I'll stop sharing. Okay.
Hi, everyone. Welcome to another science webinar. My name is Marty, and I'm the science teacher at the Delphian School. With me today is Simon. Simon is a recent graduate of Delphi who is with us today and helping us with the broadcast. If you have any questions or comments, send them in the Q&A box, and Simon will be able to read some of them off and that sort of thing. Do you know, I remember someone, it was my grandfather who told me that, let's see, what was it? A man who enjoys his work, a man who enjoys his job never has to work a day in his life. And that's true for women too. A woman who loves her job never has to work a day in her life. So I would like to suggest to you that you find something to do when it comes time for you to go out and earn a living, that you find something to do that you just love doing and somebody pays you for it. Wouldn't that be great? I had this idea when I was in college. I had that same, what would I really enjoy? And I thought, well, either a bed tester, mattress tester, or an ice cream taster. I figured somebody's got to do it, but it never happened. But instead I'm doing science, which I love. So I hope that you find something that you love. Science is a great, interesting, fascinating subject. And there are so many fields of science. We're gonna jump right in here, and I'm gonna show you this first thing that I did yesterday. I made this. I don't know how well you can see it, but what I did is I took a container like this size, and I put sand in it, and then I mixed 1 level teaspoon of baking soda and 4 level teaspoons. Would you bring up the recipe, please, Simon?
Sure.
4 level teaspoons of sugar, and I mixed them all together really well. And then I got a non-burnable, non-meltable little dish and put sand in it. And then I filled it up with alcohol. So you could either use the isopropyl alcohol, which is like a rubbing alcohol, which you can get at the store or drugstore or supermarket. And I put it in there until it wouldn't hold anymore. And then I took this outside, and I do this with an adult. And then I lit it. And then what happened is this. I've actually seen them bigger too, but the sugar burns and the baking soda provides carbon dioxide. And so you get this strange looking black snake. It's called the black snake experiment. So you're welcome to try that. And don't eat this, because this is just what happens is you can see all the holes here. The carbon dioxide, there's carbon dioxide that makes the holes, and that comes from the baking soda. And the burning comes from the sugar, and the two of them combine to make the black snake. So do this outside, because it would set off a fire alarm inside. I would do it here, except we would set off the fire alarm here, and I don't want to do that. So first thing you can do, there's the recipe. So whenever you're ready, you could do that. But I have a couple of fun things I want to show you.
Marty, one question.
Yes.
From Gavin and Griffin, is it possible to have any color snake?
Yes, it's possible to have any color snake as long as it's black. Yes, it's only a black snake. The black is caused by the carbon. The sugar is made up of carbon, hydrogen, and oxygen. And so the carbon, when the carbon burns, that's what gives you the black color. Okay? All right. Now let's pop up the ice cream recipe. Actually, leave the baking soda recipe on there for a little bit, because I want to show you this next. So I have this ramp here. I hope you can all see the ramp. And I have this cylindrical kind of shape, and I'm going to put this here. There we go. Now, why isn't this rolling down the ramp? Oh, there it goes. There. And why did it stop? Oh, there it, and it stopped again. What is going on here? Sometimes scientists see something and they try and figure out why that happens. And then when they figure out why that happens, they learn about the physical universe. And that's what really science is, the study of nature and the physical universe and how things work. And scientists do experiments. And maybe if I gave it a little push there, what is with it? What's going on here? If you think you have any idea what this could possibly be, and there it goes. So if you have any idea what is in here, let me know and send it in the Q&A. But now I'm going to show you this. We're going to pull up the second recipe here. And the second recipe is for ice cream. You know, I went to the store the other day. Yeah, put up the ice cream. I went to the store the other day and I was going to purchase some ice cream. And I think all the brands of ice cream that my store had, except two, had high fructose corn syrup. Now, the people who make ice cream use high fructose corn syrup because it's inexpensive, but it's terrible for your body. So there were only two brands that the store sold. I'm not going to mention the brands, but you could look next time. It's important to be able to look at the ingredients in what you're eating, so you'll know. The more knowledge you have, the more control you have, and the more responsible you'll be. So I came up with this way that you can make ice cream at home. Do you have the recipe up there? Yeah. So you take a cup of half and half. So a half and half means it's half milk and half cream. Cream is like the fatty part of milk. And you mix it with 2 tablespoons of sugar and half a teaspoon of vanilla. And you put that in a Ziploc sandwich bag and make sure it's sealed tightly. And then you take 3 cups of ice cubes and you put them in a big gallon-sized Ziploc bag. And you put something like this in. This is called ice cream salt. So the difference between this salt and regular table salt, it's the same stuff. It's just a lot bigger. See, the salt you put on your French fries is much smaller. They take this and they grind it up. There's even a recipe on the back of this for making mint chocolate chip ice cream. Ooh, but you could make this other just very simply by taking your sandwich bag full of ingredients and putting it in the gallon-sized Ziploc bag with 1/3 to 1/2 cup of this ice cream salt, zip up the large gallon container and toss it around for about 30 minutes.
Okay, Marty, we have some questions here.
Yes.
So they're asking whether they can use other types of salt, like sea salt.
I'd rather use, this salt is specifically made for ice cream. And what it does is it lowers the melting temperature. So that means instead of the ice melting at 32 degrees Fahrenheit, it might melt at 10 degrees Fahrenheit. So the ice gets a lot colder. Now, I've tried making ice cream with regular table salt, and it cools it just a little bit. It doesn't really work as well. This box is under $1 at the supermarket. I just got it at our local supermarket. And you can get something like it. It doesn't have to be this brand name. I think I actually got this at Walmart. In any case, your supermarket should have some type of ice cream salt. If you don't have that, there's another kind of salt that's used in the wintertime that's big and thick like this. So if you have ice on your driveway, you don't want somebody, or on your sidewalk, you don't want somebody walking by and slipping. So this kind of ice can be used to put on the icy sidewalk. And so what it does is it melts the ice. It helps melt the ice by lowering the freezing point. So say it's 30 degrees outside. Well, 30 degrees is below freezing. Water freezes at 32, so 30 degrees is freezing. But when you put ice on there, it lowers the freezing point and the melting point. And so now the ice might melt at, the water might freeze at 20 degrees. Well, it's 30 degrees, so that ice is going to melt. People won't fall down and hurt themselves. Okay, do we have any ideas yet on our mystery ramp?
Yes, some people ask if it's a magnet.
Nope, not magnets. There it is. Whoa, there we go. Stop.
It has a little bit of sludge in it that is really heavy and thick.
Well, that's really close. I'm gonna give you a pass on that one. So what it has, actually, it has something that's heavy and thick and delicious. What could that be that's heavy and thick and delicious?
Heavy and thick and delicious.
What's heavy and thick and delicious?
We'll say ice cream, honey.
Ding, ding, ding. That's what I have in here. I have honey. And I kept it on this cold pack. What does the cold pack do? Why would the cold pack help this experiment? Anybody have any ideas as to why that is? Why having it on the cold pack
Makes it thicker.
It makes it thicker, right? If you've ever tried to pour honey in the winter, when it's really cold out, you could be standing there for a long time before that honey comes out. But in the summer, it flows much better. Now, scientists have a special word for that, and the word is viscosity. Viscosity is the resistance to flow. So honey has a high viscosity and milk has a low viscosity, but you could say the word thickness, that's okay. Very well done on figuring that out. Okay, we have lots of things to get to today. As long as we have the ramp here, I think I'm going to show you this just for fun. I have these two discs, and there's something in them, but they're identical weight. The weights are identical. So if I start these two at the same place, this one, thank you, Simon, this one went faster. Well, maybe there was some difference here. We'll try it this way. I'll try it in front now, and we'll see what happens. It's still faster. Why, if they're exactly the same weight and exactly the same size and exactly the same shape, why would one be faster than the other? Now, I asked this question to some high school students a few years ago, and they had no clue. They had no idea. As a matter of fact, Simon over here has no clue, because if I was in Simon's, before I read about it, I had no clue either. So this is something, I can give you a hint if you want, but we'll see what happens. I'm going to take this down, and we're going to go on to our next thing. Let's see. What to do next? Oh, this is fun. So here, I have a little motor, okay? And this motor is on a little car, and the car can move back and forth. And when I flip this switch, it's going, the fan is going to go and it's going to move. So what's going to happen when I flip the switch and the fan goes on? What do you think? What, Simon?
Things gonna go this way.
You think it's going to, well, it depends which way this is spinning, doesn't it?
Right.
It could either go that way
Or
it could go that way.
right.
So we're going to try it. Okay, that's right. It went that way. Now, why did it do that? Why did my little toy car go that way? Now, you should be able to figure this out. This is pretty simple. And what are they saying?
They were talking about the two discs.
Oh, the two discs. Do we have any idea about the two discs?
Maybe one has more stuff in it.
No, they have the same amount, exactly the same amount of stuff. But I can give you a hint. Here's my hint. Have you ever seen Olympic figure skating or any kind of figure skating? And that's my hint. We'll get to it. I'll give you more of a hint in a few minutes if that's not enough.
One
But
person's saying if the weights are looser, then the wheel might be slower.
The weights are looser. Well, everything is pretty much where it's supposed to be, and things aren't moving around that much. But that's a good thought. That would certainly affect it. Now, I'm going to try this.
Okay.
Now, I don't know if you can see this. I'm just tightening this. So now I have this little plastic screen in front here.
Mm-hmm.
So now, what do you suppose is going to happen when I turn it on? Well, before we know without this, the car went that way.
Right.
So what do you think's going to happen with this little piece of plastic in there? So I'll wait a few minutes, and while I'm waiting for a few minutes, I'll give you another hint. Did you ever see an ice skater or a figure skater spin around? How do they change their speed when they spin around? Sometimes they spin around slowly. Sometimes they spin around really fast. How do they do that? How do they change their speed? So I'll let you think about that. And do we have any answers as to what's going to happen with our toy car?
Yes. Someone said it's going to go the opposite way.
It's going to go the opposite way.
Yes, and someone said it won't do anything.
It won't do anything.
Yes.
Okay, let's see. So I'm going to turn it on, and it's just sort of vibrating a lot because the motor's spinning.
Right.
So you're right, it didn't go this way, and it didn't go that way. What happens is, when I don't have this in here, the fan blows the air that way, and so the cart goes that way. It's like if you've ever been on a swing and pushed the person next to you who's also on a swing, the person goes that way and you go this way. Or if you've ever gone paintballing and you have your paintball gun and you shoot it, the paintball goes that way and your hand goes this way because of that opposite kind of reaction. So if I put this in here, what happens is it's still pushing air this way, but the same amount of air is bouncing off this plastic and moving it back the other way. So the two forces are pushing against each other, and you get no movement other than a little vibration of the car. Okay, that was very good. All right. What else do I want to show you? This is one of my toys. This is called a rattleback. And the thing that I like about it is I can spin it around. It really likes to spin. But it only likes to spin in one direction, because when I spin it the other way, it stops and spins back. If I spin it that first way that it likes to spin, it spins around and has a grand old time. And it keeps spinning that same way. It doesn't slow down. It doesn't stop. Well, it'll stop eventually, but it doesn't stop and spin the other way like when I spin it this way. Isn't that fascinating? I think that is. You know, I've said to you before, that's just a fun thing to show you. I've said to you before, science is the study of nature and the way the world works. And I think it's so fascinating to find out how things around us work. And I bet you could find something that you'd be interested in doing, whether it's working with animals or finding a cure for diseases or doing something in the field of science that you would enjoy doing. So it's something to think about. Okay, what are we going to do next?
Are we going to tell them the answer?
Sure, let's tell them the answer. What are we telling them the answer to? This one?
Yes.
Okay. See, this is why Simon's here, because I forget these things. So I'm going to take this little piece off here. Do we have any answers that as to what how do skaters spin around fast?
Maybe like a compass. Someone saying one is slicker than the other.
Is slicker? Nope. Well, you might have seen when an ice skater wants to spin around. You've seen the Olympics, haven't you?
Yeah.
So what happens when an ice skater wants to spin around fast? What do?
Put more force.
Don't know.
Yeah.
Okay.
Not sure.
They bring their hands in close to their body is what they do. They can go like this and they spin around slowly. And then they go like this and they spin around really fast. And so that's what happened here. When I have these four balls like that, it's closer in and this disc can go down faster. When I have these balls in their little outside areas, it's the same weight or mass, but it's like spinning around like that. You could try that at home if you have a chair that spins around. You could give yourself a turn and keep your arms and legs out and see how fast you turn. And then you could try it again, except this time keep your arms and legs in and see how fast you turn. I guarantee you will turn faster when you have your hands in if you're on one of these spinny chairs. Don't tip over and hurt yourself. But that's how this works. Isn't that interesting? I think that's interesting. And this is something that ice skaters know, or yeah, because they use this. If you watch them, next time you see some ice skaters, you watch their hands when they want to spin around fast, and they bring their hands in close together.
Someone has a question. They want to know what half and half is.
Oh, half and half is something you could buy at the store, and all it means is it's half milk and half cream, which is the fatty part of milk. So that's all it is. Half milk, half cream. They call it half and half. Okay, you might have seen one of these guys before. The balancing eagle. Now it doesn't look like it should balance because it looks like it looks like this part should fall down, but it doesn't. I could balance it on my finger, or I could balance it on its little perch here, and it goes right at the end of the beak. So how does that work? I have a way of showing you in just a minute, but let's see if anybody knows. I'll bring that up there. And in the meantime, we're going to do this next. Oh, I'll show you this one first. I have lots of toys in my lab. That's one of the advantages of being a science teacher. I get to keep lots of toys in my lab, and this is one of them. And this, if I can put this down there so it's nice and stable. There we go. So I'm going to take this and I'm going to put this. So this is just a little plastic ball, and this is a little piece of plastic that it's on. And I'm going to take this and push it back and let it go. And what do you think is going to happen when I do that? Well, either the plastic and the ball will go flying out this way, or just the plastic will. What do you think? It actually depends on how fast and how hard I pull it back. If I pull it back a little bit, well, let's see. Okay, that time everything went flying. That's one of the things that could happen. Or it could do that. So if I give it a really big push, there was enough friction here to pull the ball along with it. But if I just gave it a little tap, this went out and the ball flopped down. Okay, do we have any ideas on the balancing bird?
They're saying that the head weighs heavier.
The head is
Weighs
heavier.
more. Yes.
Well, you're close. Something weighs more, certainly. But it looks like the head, it's balancing right here.
Someone says it has weight in its beak and wingtip.
It has weight in the wingtips. It does. So I'm going to show you this. Who was that came up with that idea, Simon? Who was it that thought the wingtips
I don't know.
had weight? Is there a name that goes along with that bright idea?
Probably.
Okay. Well, here's sort of a model of that you can see. So here I have these two magnets that give you extra weight, there and there. And now, let's see if that balances. Not quite. I want it to balance more, so I'm going to bring these magnets out a little. That's the nice thing about this. You could see what happens. Okay, so that might be a little too much. So I'm going to try it right there and right there. Let's see how that's not quite enough. I want it to be perfectly balanced. That's pretty good. Looks like that needs to go out a little bit. There we go. So this is how this balancing bird, the other balancing bird, works. The only difference is there are weights in the wings that you can't see. But this is something that I got to show you how it works. So you can see there's a magnet on both sides, and these magnets are not terribly strong, but they're strong enough to hold on to each other through this little piece of wood. And so that's how that works. Okay, now we get to some other fun stuff. Ba-dum-bum-bum. Here is a wooden, two pieces of wood. It's held together here, and they have two little cutouts at the end here. So if I take it like this, and I put this here, it rolled down that way. Well, maybe the table's not balanced. That could be it, right?
Yeah.
That could be it. So I'm going to move it around this other way. That's what I thought the first time I saw this. I thought, well, the table's not balanced. So now I'm going to try it this way, and the same thing happened. It still rolls down. It's still rolling down. I'm going to hold this so it doesn't slip apart. Oh, you'll hold it. Thank you, Simon. Well, maybe if we tried it this way.
Still did.
What if we try it this way? So if you think you know why this does this, send your answer in, use the Q&A box. And while you're doing that, I think I'm going to show you something else. Do you know, phone lines used to send their messages in the ground, and they used to be along copper wire. But these days, they go along glass, or something called optic cable. And I have something here, this piece of plastic, kind of an unusual shape. And it's going to show you there's something plastic optic cable has, or glass optic cable has, something called internal reflection. And what that means is, if it's a tube, a glass tube, and when the light goes this way, it bounces and it can go around and it stays inside the glass tube. So I'm going to turn this, let's see if we can see this here. Can you see? Well, you can see, I'm going to point this to you, toward the camera. So can you see the light coming out the end?
Yes.
I don't know that you can see it. Let's see if we can see it right there. You might be able, can you see that?
Yeah, you can see this.
Yeah, you can see this here. So the light is bending and staying in the tube.
Yeah.
That's internal reflection. That's how a lot of these things work. A lot of these optic cables or telephone lines work. And they found out this is a lot cheaper and it can hold a lot more information and a lot more phone calls. So this is what they use. And this will stay like that for many, many, many years. Copper will start to deteriorate and not work so well. So that's just one of the advancements that were made. Okay, do we have any ideas on this?
Yes, someone said it doesn't fit where you put it, so it rolls to where it fits.
Well, why would it do that? That's a good idea, but why? Why would it roll to where it fits? Okay.
I'll give an answer, or?
Sure.
Not quite?
Sure. So this is a really sneaky thing. Don't feel bad, because when I first saw that, I couldn't figure this out. So, and I showed this to another teacher, and another teacher who didn't know the answer said, why does it do that? So up here, look at how high above the wood this piece is. And as it goes down the ramp, this gets wider and wider. And so it's touching a lower and lower and lower piece of this shape. And so it's first touching here, and then as it goes down the ramp, it's touching lower and lower and lower. So it's actually going downhill, because look at how high it is here. Look at how high above the wood it is here. And look at how here it's right on the wood.
Right.
So it's actually going from this high position. Look at how high it is above the wood here. It's going lower. Look at how high it is above the wood here.
Lower and lower and lower.
Look at how high it is. Now it's touching the wood, and now it goes in. So no matter which way I turn it, because of the shape of this, it's always going downhill. Okay, that's just fun. I think it's fun. It's interesting.
Yeah.
Okay, what next? Well, let's see. Let's try
The bottle one, or?
the bottle.
Yeah.
Any matches in here? Or do I have any matches in my pocket? Or did I bring a match with, good science teacher always has a way to light things on fire in his pocket. So this is just a burner type of metal, and there's alcohol in here. And so if I light it, the alcohol should catch on fire. I don't know if you can see that at home. You can see it now.
Yes.
See it?
Quick question. They want to know where James is.
I don't know. Where is James? Do you know where James is?
No.
I don't know where James is. So if I take this, and this is just a plastic water bottle, what's going to happen when I put this flame? I'm assuming you can see the flame. Maybe I can put something behind it. So you can, will that help you see it better?
Yes.
Okay. How about the red? Would the red be better? Red or black? It doesn't matter much.
Yeah.
Okay. or red or blue. So what's going to happen when I put this plastic water bottle, of course the water's out of it, in the flame?
Someone said it will melt.
Of course. Whoa, did you see how fast it did that? Look at that. It melts. Well, it's a good thing I don't do that for too long because it's kind of smelly and we don't want to set off the fire alarm here. So now I'm going to take this, and here I have a similar water bottle, but there's water in it. So now I'm going to heat this up, and I'm going to raise it up just a little bit.
Okay.
And it should have melted by now. What's happening? I don't know if you can see this, but the water inside is starting to bubble and boil. Now, eventually, this is going to break. The plastic's going to break, and it's going to go all over the table. So before that happens, I'm going to shut it off. But the water inside, can you feel the water, how warm the water got? The water absorbed the heat. Now, I had a friend who had a water bottle, and it had a cap on it, and there was a campfire, and the campfire, it was burning, and I don't know if you can see the little bubbles in there, maybe not. The campfire was burning, and so this friend had a water bottle that was sealed, and he said, I wonder what happens if you take this and you put it right on the red, hot, glowing pieces of wood in the campfire. And one person said, the jar's going to melt. And the other person said, nope, the jar's not going to melt. First, the water's going to boil. And after the water boils, then the jar might melt. And so they tried it. It's like a good science experiment. The other day we were talking about the scientific method. I wonder what would happen if. And so scientists do an experiment and then try and figure out why the experiment turned out the way it did. And that's how they learn about how the physical universe operates. So here we have the water. And so what happened is he put the top on it, brand new bottle of water, just like this, put it in the hot campfire, and it didn't melt. The water in here got hotter and hotter and hotter until it started to boil, and then this broke. So it's the water. Boy, there are lots of little bubbles here. We'll talk about that in a minute. The water in here will absorb the heat and get hotter and hotter and protect the outside from getting burned. I thought that was interesting. Okay, now I'm going to try, as long as I have the water. Thirsty?
No.
No, oh, I didn't think so. Okay, so now I'm going to put some water in here. Well, let's see, which way do we want to go? Let's do this first. I have here some cereal. Have you ever done this experiment before, Simon?
No.
This is cereal. This actually is a cereal called Total, T-O-T-A-L, because they say it has the total amount. I'm looking for something here. No, maybe this will work. I don't find exactly what I'm looking for. Maybe this will work. The total amount of different things you'll use. So if I put it in here, can you see it floating? And now, if I put it here, I'm moving it this way. And now, if I move this here, come on, I'm moving it this way.
Wow.
So what happens is, there's iron in this cereal. And so the iron in this cereal is being attracted by the magnet.
Oh, wow.
Isn't that interesting?
Yeah.
Now, I'm not saying that your body uses all of this iron efficiently. It might be able to use some of it. Sometimes iron has to be in a certain form for your body to absorb it. But your body could probably absorb some of this.
Mm-hmm.
But I thought that was interesting. Now I'm going to show you something, and then let's see if we can figure out why that happens. So here I have 2 toothpicks. I want to get 2 round toothpicks. 2 round toothpicks. Can you see it okay?
I'll move it forward a little bit.
Move it forward. Okay, there we go. So I want these 2 toothpicks like that. Okay, now I'm going to take a little bit of soap, whoops, and I'm going to put it right between the 2 toothpicks and watch what happens. Did you see that? The 2 toothpicks were close together. Try it again. I don't know if it's going to work again. We're going to do a science experiment and see if it works again. No, it didn't work.
No.
So what happens is there's an attraction for the water. The water in here has an attraction. It's called surface tension. Sometimes you might have noticed if you fill up your glass, you could fill it up over the rim, and it still is over the rim, but it still doesn't spill out. That's because of this thing called surface tension. And when I put the drop of soap on here, it broke that surface tension, and that's why the 2 toothpicks separated and went in different directions.
Mm-hmm.
Okay, what else do we have? Do we have any questions?
Nope.
No questions. Okay, this is one of my favorite. I did this the other day, and someone just said, I don't understand this. So I'm just going to see if I can put some water in here without my finger getting stuck. And now I'm going to take this cork, and I'm going to wet the cork a little bit, but it's still pretty snug in there, isn't it?
Yeah.
So I'm going to take this, and I'm going to
Put it all the way in.
there it is, all the way in my bottle.
Mm-hmm.
I shouldn't have done that, should I?
Yeah.
Well,
Right,
how do I get it out? That's the question. How do I get if I could shake this all day, it's never going to come out, is it? But oh, look at that though. And I can't grab it in there.
Yeah.
But how can I get this out? Well, there's a way science can help. It just so happens I have one of these bags that I got at the supermarket before they stopped putting things in bags. Do they put things in bags where you are? Do they have bags available? In Oregon, they don't have bags. They don't give you plastic shopping bags anymore. And there's a good reason for that, and that is they don't want, this can last many thousands of years and can make a mess if it's put in water, and not good for the environment.
Yeah.
So, but if I put this in here like so, and open this up, and turn this upside down, and blow into it, and now take it and isn't that amazing?
Wow.
I saw this experiment and I said, wow. So if you have any grown-ups around the house, you could really surprise them with the science that you know now by doing these experiments. You know, you have a chance now, you have some free time to explore whatever you're interested in doing. When I was a young man in school years ago, if I wanted to find out about something, I'd have to look in the encyclopedia that I had, that my parents had at home, or I'd have to go to the library and hope there was a book about the subject.
Mhm.
But you guys are so lucky because you have the internet, you have the world of information at your fingertips, and you could find out about so many things so fast. It's incredible. So I hope you'll find.
Marty, before we end off, can you do that thing one more time? Someone missed it.
Someone missed it. Oh my gosh. Okay. There it is. I don't know if this is going to work a second time. I might have to get another bag. We'll see. So I just put this in here. Now, we talked about this not wanting to come out.
Right,
You
doesn't
could
work.
shake all day. It's never going to happen. So I'm just going to take this and put this in here like that. Turn this upside down like that.
Mhm.
Blow into it. And I want to see the bag. And then I take it and I just pull it right out. Isn't that amazing? Isn't that interesting? It's the air pressure that does it. So when I blow it in here, now there's pressure in the bottle, but this gets caught up when I'm pulling it out.
Mhm.
And so that's how that happens. Anyway, now you've seen it a second time, so you know that it works. But I just wanted to tell you to use this opportunity to get curious about something. You know, curiosity is the cure for boredom. So if you're feeling bored, find out something that you're interested in doing. It could be science, it could be medicine, it could be blowing things up. It could, only with an adult present, please. I don't want you to get hurt. And find out about what you're interested in, what you find so fascinating, and do research about it and find out more about it. And maybe the time will come when it's time for you to get a job where you can get a job in that area. But this is your opportunity. Doesn't happen very often. This is your opportunity to find out about something you are interested in and learn to do and learn about what subject you're interested in. So I hope you stay curious and have a wonderful adventure. And until next time, we'll be seeing you. Thanks for tuning in. Bye for now.
Bye.